Inequalities. So we're going to talk about true and false questions when it comes to inequalities. And now that we've spent some time with equations, we're going to spend some time with inequalities and see how they're different and how they're very similar. So when we found a solution to an equation, we checked it to see if it was true. Well, we can do the same thing. We can determine the truth value of an inequality, but we're going to see something which I think is kind of interesting when it comes to the inequality and the truth value, okay, to determine whether it's true or false. So this first one, 7 is greater than 3, clearly true. Skip over to C. Is 9 greater than 12? Clearly that's false. Is 4 less than or equal to 4? Now that's an or statement. Is it less than or is it equal to? Well, it's equal to, so that makes it true. Letter F, is 3.5 less than 4.2? And that certainly is true. So real basic inequalities. So now let's take and dive into it a little bit more. It says, consider the statement -8 less than 4. Do you think that this is true or false? Well, we clearly know that that is true. And why is that true? Because -8 lies to the left of 4 on the number line. Trying to write in, not in cursive, okay, printing. I had some kids complaining that they couldn't read the cursive, so I'll do my best. So the inequality definition, I'll let you guys pause the tape and read that. Okay, I'm not going to spend time reading that, but certainly read it, understand it. Okay, so we're going to hop over to the next page. So we'll flip that over. So now let's dive into and let's actually see a bigger inequality here. We've got some algebra involved, and we want to determine whether this value that they give us, 10, is it true or is it false? Okay, I just had to pause that because I want you to use your calculator on this. So 3, we're just going to substitute that 10 in. So 10 minus 2, is it greater than or equal to 2 times 10 plus 1? And now let's do the same thing that we did when we were checking our answers or our solutions to our equations. So we go to our calculator, we show the substitution step on our paper that I just did, and I'm going to type in exactly what I wrote on my paper. So where do we find those inequality symbols? So if you hit Control equals, got a little menu that pops up, pick the one that you need, and then continue on to, and 10, 2 times 10, plus 1. Enter. Awesome. Okay, so it's true. So that's how we will check our truth values for our inequality. So that inequality is true for the value of 10. So let's now see if this inequality is true for the value of 5. So do the same thing. 3 times 5 minus 2. Is that value greater than or equal to 2 times 5 plus 1? So I'm still dealing with that same inequality. So when I go back to my calculator, I'm going to cut and paste and then just edit. So if I arrow up and highlight, I'm just going to hit enter. It brings up that same inequality, but now instead of the 10 in there, I'm going to put a 5 in its place. So now instead of typing in that whole thing, I can just go in and edit. So it saves a little time. And delete that 10 and put a 5. And let's see, did that work the way I wanted it to work? I think I've got to move my parentheses. Got something that, there we go. Okay, so now it looks exactly the same. We hit enter and we find out that 5 is false for that inequality. Okay. All right, so you see how you can test values to see if they are true or false given the inequality. So now it says, notice that unlike equations, inequalities tend to have many values that make them true. Okay, we just tested one that was true and one that was false, but we're going to get into, and we'll discuss later, that inequalities have an infinite number of values that make them true. Okay, which is kind of cool. Where an equation just has one, a linear equation just has one solution that makes it true. So let's go down to exercise 5, and we're going to look at letter B. It says, for each of the following inequalities, determine if it's true or false at the given value for the replacement value or variable. Okay, so similar idea. Okay. -3, but something a little bit more complicated looking, shall we say. -3 plus 7 divided by 2. So, I don't know, let's do this one by just some mental math. We've got, that's 9. Is that greater than or equal to 4 divided by 2? Is 9 greater than or equal to 2? Okay. I think I did that wrong, because what did I leave out? I did. Sorry about that. Let's back it up. And let's squeeze, I forgot that 5 in there. That's clearly going to change our answer on the left-hand side there. So this right here gives me 2. Now I have -3 times 2, which is -6. Is -6 greater than or equal to 2? That is false. Okay. All right, so you see what you need to do to check the truth value of those. All right, and again, you can still enter all of this into the calculator. Make sure that when you do it, so let's do D together, and we'll put that one on the calculator. And I always say, show your substitution on your paper, and then once you go to the calculator and enter it all in, before you hit enter, make sure what you've typed in on the calculator looks exactly what you have on your paper. So what do I mean by that? So let's take and check that one. So 2, and I had parentheses, and I had 5 minus 5, and then outside the parentheses I had plus 1, and that is all divided by. Now you'll find that you can do this in a couple different ways. I forgot to hit the fraction key to start, so I'm going to put that whole thing in parentheses because that's my whole numerator. And divide. I don't know what just happened there. Let's go back. I don't know why it hit answer. So we'll backtrack, and I'll start out with my fraction key. There we go. 2 parentheses. 5 minus 5, and still in the numerator, plus 1, and that's all divided by, divided by 3. And then over here, that's where I've got to pick my inequality symbol from. So control equals, and I need a less than or equal to. Seriously? I am not sure why it keeps doing that. I don't think there is a backup button. I wonder, because all right, let's see what happens here. Five minus 2 divided by 9. I'm wondering if because my piece was highlighted there when I selected. Let's see. Enter. Nope, that clearly is not what I was looking for. So let's try that one more time. Pick my fraction. This is good that I'm encountering these problems, because if you guys were trying this on your own, I'm wondering if you would be having the same problems. And then, of course, I've got the stylus that I'm working with here. Plus 1 divided by 3. Uh-oh. You know what? I'm wondering. Sorry, guys. All right. Last time. I'm going to do this with the mouse instead of the stylus. Goodness. -5 1. I'm going to try it without the fraction key. Divided by 3. Okay. Then pick that. I'm going to go with the fraction key. 5 minus 2 divided by 9. True. Yes. Phew! Look at that. It changed that into the fraction for us. Sorry that took so long. All right. Let's go to the next lesson. Got to make up some time here because I just wasted your time just now with that. All right. So, next lesson. So, we've got sort of our simple inequality here. It says where 4 is greater than 8. So it says when we were dealing with our equations, we dealt with our 3 properties and then our new properties that we added onto it, the additive and multiplicative properties of equality. Well, all 5 of those properties still apply to inequalities. So it says consider the true inequality 4 is greater than 8. So if we said, okay, 4 is greater than 8. And if we add 3 to both sides, so 3 plus 4 and 8 plus 3, is that true? Is 7 less than 11? Right? 4 is less than 8. If we add 3 to both sides, is 7 still less than 11? Yes, that is absolutely true. So what if we multiply both sides by 2? So we take that same inequality, 4 is less than 8, and we multiply both sides by 2. Do we still get a true inequality? Is 8 less than 16? And yes, that is absolutely true. Okay, so we can, I'm going to tell you that if you do the same over here with B and D, if you subtract 4 from both sides, you're going to get true. If you divide by 2 on both sides, you're going to get a true. But it says, based on exercise 1, you might conclude the truth value of inequalities have the same properties as the truth values for equations. Okay, equalities or equations. But there is a huge difference between the two. So I think this is mind-blowing. Blows my mind every time I think about it. It says returning to our true inequality. So we're sticking with that 4 is less than 8. So now what if we change this idea? If we multiply both sides of the inequality by -2, what is going to happen? So we would think, oh, it should still be true. So if we take -2 times 4, is that less than 8 times -2? So we have -8. Is that less than -16? Is -8 less than 16? No, that's false. So let's do the same thing now, but let's divide by a -2. So that same inequality, we take 4 and divide by -2. Is it less than 8 divided by -2? Still doing legal moves here. Okay, we're dividing both sides, but -2 is -2 less than -4. That is false. So you guys have probably known that when you multiply or divide by a negative, what do you have to do to the sign? Okay, the inequality sign, you have to flip it. And this is the reason why you have to flip it, because when you multiply or divide by a negative, okay, it takes that true inequality and makes it false if you don't flip it. So it says the addition and subtraction properties, okay, if A is greater than B is true, then, right, A plus C is greater than B plus C. That's always true. But now let's take multiplication and division. It says if A is greater than B is true, then C times A is greater than C times B will be true if C is a positive number. Okay, and the same inequality, okay, or flipped, we took and we flipped, our symbol will be true if C is a negative number. So that's why when you multiply or divide by a negative, you have to flip that inequality symbol to contain or to maintain the truth value of your inequality. Okay, so let's go ahead and flip it over. And let's play with these a little bit. So I've got, it says, solve this inequality by applying properties of inequalities that we found earlier. So what would we do? We'd add 3 to both sides. We'd get 4x is greater than or equal to 8. We would divide by 4, and we get that. Now it says write 5 numbers that make the final solution true and plot them on the number line below. X has to be greater than or equal to 2. So I would say, well, 2 would make that true. 3 would. 4 would. 7. Okay. And say 10. All of those, okay, values make this, let's say 7, 8, 9, 10. All of those make this true. But what about all the other ones that I didn't mention? Okay, so you know that we would shade that in. That indicates everything to the right and including 2 make that inequality true. Okay. A couple more and we're all done. So this next one, we've got rewrite the left-hand expression, so this side, as an equivalent expression using addition. All right, so what do they mean by that? So an equivalent expression, what would we do? Okay, we would say negative 8 plus 8 minus 2x. Is that greater than 16 minus 8? So we're essentially just using the, or that additive property of equality. Okay, so we know now we could take and continue to solve that. So what happens there? Negative 2x is greater than 8. We have to divide by that negative 2. Now be careful, okay? So x is less than negative 4. Pick a number that is true based on your solution. So our solution with x is less than negative 4. Well, what if I pick negative 5 and show that it makes the original inequality true? So our original inequality, 8 minus 2 times negative 5, is that greater than 16? We're checking that truth value. I'm not going to go to the calculator. I'm just going to do this. Is 18 greater than 16? Yes, that is a true statement. Graph the solution on here. So here is my solution that we have checked with a value. And at negative 4, 1, 2, 3, negative 4. Now notice I picked negative 5 because the values of x have to be less than negative 4, not equal to. So to indicate that it can't be negative 4, it can get real close to negative 4, okay, but it can't be equal to. And then I would shade everything to the left. Okay, and this last one, using all of our properties, if we take and we solved this inequality, 8x minus 16 minus 6x minus 3 less than or equal to 7x plus 4 minus 3x minus 3. Wow, a lot of combining like terms to do. 2x minus 19 less than or equal to 4x plus 1. I'm going to subtract 2x from both sides. And I think I'm going to add or subtract 1 from both sides. I'm going to move things kind of all at once. Negative 20 is less than or equal to 2x. Divide Now I'm not dividing by a negative. That 2 is not negative, so I don't need to flip my symbol. But notice how it's written. So if I read from left to right like I normally do, negative 10 is less than or equal to x, I always tell kids, read from the variable if it's on the right-hand side. So in this case, I want to read backwards. My value of x has to be greater than or equal to negative 10. Okay, my value of x has to be greater than or equal to negative 10. So by all means, take that negative 10, plug it into the original equation, plug that whole thing into your calculator, see if you get a true value. Because negative 10 is equal to, so you could pick that, or you could pick any value that is greater than negative 10. So it's equal to all the values that are greater than negative 10 to the right.